Hello friends, today we are going to study INT element which is available in all the molecules or in all the objects. So uh, the symbol for this identity is E, and if you take any molecule, uh, we say that identity element is available. The reason is that for identity element, proper axis of rotation is 360 divided by 360. That is, when we rotate a molecule by 360 degrees, it comes back on its own place. That is, we can also say that identity molecule is equal to doing nothing to the molecule. So operation of doing nothing to an object is also called as identity operation. And every molecule is in distinguishable form from itself, and if nothing is done to it, that is, it produces at least only one element, that is E. So if, for example, this molecule which is on your right side, if this molecule does not contain any other element, that means it has got only one and only one element, that is E. And such molecules are said to be asymmetric molecules, and they are chiral in nature. So now next, let's learn the what will be the Cn value for identity element. We all know that Cn, that is axis of rotation, is C, and n is given by the formula n folds of rotation, and formula for that is 2 pi by theta, that is 360 divided by angle of rotation. So for considering this example, for identity operation, what will be Cn value? Now if you solve this equation, that is 2 pi, that is 360 divided by angle of rotation is E, for E is 360, because as we said, doing nothing or rotation by 360 is the place where your molecule will come on its own place. So that is 360 divided by 360, it comes out to be 1, and n value for E will be 1. So E is nothing but C1 rotation on any molecule which it gives after rotating by 360 degrees. So if a molecule does not belongs to, it does not have any other operation, any other element like mirror plane, inversion axis, or proper axis of rotation, it has only one rotation, that is C1, and it is nothing but E. Now let us learn the consequences of this identity element. For example, we will take ammonia molecule, and in ammonia molecule, if we rotate by C3 by holding a nitrogen molecule as a axis passing through only nitrogen, after 120-degree rotation, one C3 is obtained, that is, all the hydrogen will replace each other's position in clockwise direction. Second rotation in the same direction clockwise will result into next C3 operation, and third rotation in the same direction will result into C33. That is, if you notice carefully, the hydrogens which are rotating by each operation, object number 1 and object number 4 are equal. That is, number 1 hydrogen has rotated clockwise to 120-degree position, again to this position by 120 degrees, and again to the original position, identical position to the first molecule. That is what we obtain as a identity. So this equation, that is Cn raised to n is equal to E, is valid for any type of rotation, be it C2 raised to 2 or C4 raised to 4. The operation by the two C2 operations will lead to E, or four operations of C4 in nature will lead to identity. So that is the E operation.